Okay, so in this module, we're looking at multiplying and dividing exponents. We're going to start with our simpler cases first before we move into more of the trickier concepts where we're dealing with power of a power. We're dealing with an expression that needs multiple steps and multiple process in order to be simplified or evaluated here. So we'll call this part A. And we're looking at multiplying. Okay. Part B we'll have on the same kind of side. It will be the division part. So it gets a little bit complicated because you have exponents, but you're ultimately multiplying terms. Okay. The difference in terminology is super important. So you're multiplying terms, but you're actually dealing with the exponents in a slightly different way. What you're going to do is you're going to add the exponents to common bases. So, in my opinion, all that sounds, pretty abstract. I'm not going to lie. It's much easier with number results, right? Or trying practice questions beside. So, let's look at our first example. We have 2 to the power of 5 times 2 to the power of 8. I have kind of like a color coding system going on here. I'm going to keep the bases as blue and the exponents as purple. So you'll notice I've already kind of underlined the first one. Our base is 2. Note that the base can be a number or it can be a letter. Okay. In this case, of course, 2 is a number, so our base is 2. Okay. Let's say one of these was 3. Like, let's say instead of 2 to the power of 8, it was 3 to the power of 8. You can't simplify it with exponent laws. They must be the same base. Okay? It's like adding or multiplying apples to apples. You can't do apples to bananas. You can't do like circles and squares. Anytime you are essentially collecting in math, it's gotta be the same term. That's key. So, let's start off with this one. So you have 2 to the power of 5 times 2 to the power of 8. Your first step, I'm going to write down the base. Okay, my base always stays the same. Note, it never changes. So base is 2. We are multiplying these terms, but what that looks like, 2 to the power of 5 is the same as 2 times 2 times 2 times 2 times 2, if we expand it out. Same thing with 2 to the power of 8. That 8 represents the number of times the group of 2 is multiplied. So it'd be 2 groups of 2's multiplied together 8 times. Okay. It's going to get ridiculous the higher your exponents go, right? Your calculator won't be able to take those operations to evaluate. And you also don't want to be expanding all the time. What if your exponent is like 1,000, right? You don't want to be writing all day just for one question. So this is where exponent laws comes in handy. You're going to take whatever your exponents are, and you're just going to add them. Okay, I have 2 exponents. One is 5, one is 8. Just going to add them together. And my final result is 2 to the power of 8. This is called simplifying. Okay, so again, this is a simplified. Okay. If we were asked to evaluate, which we'll get more into in a little bit, you're going to take that value to the power of 8, you're going to plug it into your calculator. The key is often when you're performing the exponent laws, it will simplify to something that is manageable in your calculator. So on your quiz, you're not going to have a simplified answer of like 2 to the power of 1 billion, right? And then be expected to calculate it. It's going to be something reasonable. Likely under a power of 10, depending on your base. So, let's try a couple more. So, let's say we have a letter this time, because we haven't dealt with a letter yet. Say I have k to the power of 7. And yes, I picked it because my name starts with it. Okay, so k to the power of 7 times k to the power of 3. Very much the exact same process. The only difference is dealing with the letter. Okay, so my base is my letter. My exponent is underlined in purple. So Same exact idea as above. K stays as your base. And your exponent now becomes 7 plus 3. This might bother some people because we're not really used to dealing with like unknown values in this sense, right? We've probably only dealt with exponents in relation to quadratics or area and perimeter in grade 9 word problems where then you had a value you subbed in. But don't worry, just treat it the exact same way. Okay, as what you did with the number. So again, simplified, k to the power of 10. Can we evaluate answers with letters as a base? Okay, or sorry, I guess I should be more specific, simplified answers. Okay, can we evaluate those if they have a letter as the base? No. We could never just get like a numerical answer for this. That would unfortunately never work out. So that's what we're left with. One example with a number, one example with a letter. What if, let's go a little bit further with this. What if we had this? Okay, so instead of just having 2 terms, what if we had 3? There is also an example in the module that goes through a couple of these as well, but I think for visual learners, it'd be much easier just to see it. So same thing, my bases are all good. If they were not the same, I can't simplify, right? So they gotta all be the same. I have exponents, very similar as the first question, notice. So you have a number as the base and then different exponents. I am going to take my base, set it into place right here. It's the number 4. Apologies, my 4s kind of look wonky today. And then you are going to take all of your exponents. The process does not change, right? As you move from 2 terms to 3, you're still just going ahead. You're adding up all your exponents. The only difference is you have that third exponent that you're going to add. So 2 plus 5 is 7. Okay, and I'm on this step right here, looking at these guys. 2 plus 5 is 7, plus another 6 is 13. Okay, so that's what we're looking at. That would be a pretty large number put in the calculator, but if that's the case, then you would probably be asked for the simplified version. Let's do maybe one more, because I just thought of another case that might come up. What if you had something like this? Okay, we haven't really looked at a negative exponent. So what I've done is I've simplified a lot of the materials for today because there's a lot of different cases, right, that could occur with these exponent laws. We're only looking at the negative if it's just multiplied or divided in, not any of the complex examples. So, sorry, not that this isn't complex, it certainly is. So same thing, we have a base of k, and we have a couple of exponents. You're going to follow the same process. So you have k as your base, and then you're just going to take your exponents and add them. The only difference is the 4 is negative. So you're just going to use some light integer rules to make sure that you get the correct exponent on your letter. Best way to think about integers is temperature. So it's -4 outside. It goes up by 6 degrees, right? Which are, temperatures for fall, spring, right? We experience those. So -4 outside, adding 6. Okay, well, we know if we were at -4 and we add 4, we would be at 0. So adding by 6, we're at +2. If you wanted to, okay, especially with integers, if it helps, you could simply draw out a number line. You're at -4. You hop over by 6. And sorry, folks, that is my guard dog here. Anyways, this is real life. Okay, so k squared. Okay, so you're doing the exact same work as the previous ones. You were just adding by a negative value. Okay, and that's it. You won't really see a lot of those. You're going to see mostly cases like 1, 2, and 3. Okay, so what about division? So part B, we're going to do some division. Okay, so division. Look at how we multiplied. So we added the exponents when we multiplied. What do you think we're going to do when we're working with division? Okay, you probably got it. You're going to subtract. Going to subtract those exponents. Kind of like how x's lie, exponents lie. Okay, they're not truthful. So that is what we're going to do. We are going to subtract our exponents. Okay, so we're going to start off kind of similar as the left side, and we'll just do different examples that kind of reflect the same levels of difficulty on the left side, except this time we are looking at division. You might get something like this. Okay, and I often show it vertical as a heads up. It could also be written like this. Okay, horizontal. The reason I don't tend to write it like that is I just find I get confused with the operation. I find vertically it's easier, but if some of you, if it works better writing it horizontal, by all means. Okay, I just find vertical, it's a little bit more clear as to what I'm supposed to do. So, same thing. Let's check if our bases are the same. Yes, they are. Okay, bases are both 2. And I have my exponents. They're 8 and 5. All I'm going to do is follow the same sort of recipe that I did on the left-hand side. My base is 2. My exponents, I'm going to take them and subtract. Okay. Follows very similar procedure as the left-hand side with multiplying. The only difference is you're subtracting. Okay. At this point, I wouldn't give you one that gives you a negative exponent as a heads up. Okay. Oh, whoops, I can't spell. There we go. Okay, whew, luckily we're not in English class. All right, so 2 to the power 3 is our simplified expression. If I was asked to evaluate, I'm going to take 2 to the power 3 and I'm going to plug it into my calculator. That exponent tells you how many versions of repeated multiplication there are for groups of 2. I think it'd be easier just to show you. So 2 to the power 3, this 3 tells you number of times 3 is multiplied. So it would be 2 times 2 times 2. So if you want to expand it out, that's what it would look like. And then finally, if you want to evaluate, 2 times 2 is 4, times 2 is 8. So a lot of math terminology stems from simplifying and evaluating. Simplifying is gathering the expression in a sense, collecting things, right, of that nature. Evaluating, you get a whole number answer, okay, or you get a numerical value. Let's try some more. So let's say we had b to the power of 7 over b to the power of 6. So same thing, you have your base, it's right here. It's going to be a letter this time, but we've already dealt with a letter on the left-hand side. We know what we're doing. And then we also have exponents of 7 and 6. Okay, so exact same thing. I'm going to set my base down as 7. And I'm going to subtract. So 7 minus 6. And b1. B to the power of 1, or just b. Can we evaluate? No, because again, it's a letter. So we just leave it alone exactly how it is. Okay. Let's try a couple more. So let's try kind of a funkier example. What about this? So we have 4 divided by 4, 4 to the power of 4 divided by 4 to the power of 4. Okay, right away, some of you might say, I know it's 1, right? Anything divided by itself is 1. If you are unsure, follow the same procedure. So I'm going to underline my base in blue. I'm going to underline my exponents in purple. I am going to take my base, which is 4, and try not to get confused. There's a lot of 4s here. And then you're going to take 4 minus 4. And this is actually going to tie in another exponent rule that we're going to look at. So we apply our same logic. 4 minus 4 is 0. Okay, and then hopefully you saw some information about the 0 rule. Anything raised to 0 equals 1. Anything, so whether it's a billion raised to 0, it equals 1. Whether it is negative 4,000 raised to 0, it's 1. 0.5263754 raised to the power of 0 is still 1. And of course, we get a numerical answer. Boom. So this is simplified. And our numerical answer is evaluated. Okay. So again, just the key difference in when you simplify versus when you evaluate. Okay. Right there, if you can do that, you can likely do the quiz, no problems. But the more you practice, especially with exponent laws, the better. And I'll post some extra practice, okay, just so you get the help you need.